Rumors of my replacement are slightly exaggerated. I'm Ray Myers. Welcome to Craft vs. Cruft. And today and in the next few episodes, I'd like to finally address the talk of the town in the tech world, which is AI, and particularly some innovations put out by OpenAI in the form of their ChatGPT chatbot. Building on a lot of previous work in what are called large language models, and what some of the implications are. There's a lot of different applications. We're going to be talking about something today central to this channel's mission of improving software. A lot of people are talking about the capability of using a GPT to generate code. As it turns out, our bottleneck is not, as an industry, our ability to generate new code, or especially code of dubious quality. Our challenge is, what are we going to do to manage all the code that we're already running? So let's take a legacy code spin on GPT, in particular the new model that was released days ago, GPT4, which motivated me to do this episode based on it being significantly better at working with code than even GPT-3 was, which was already quite impressive. So for reasons I'm going to go into in the future, I don't think that anyone's saying that programmers' days are numbered, that this is going to wholesale replace coding as a profession. I don't think that that is warranted. But before I say anything, dismissing the capabilities of this, I want to first show you just how impressed I am with what it can do. I think there's reason to be excited as well. So, without further ado, I'm going to give you a taste of what's possible, and then we're going to get to some prompts I've been playing with to try and get more methodical with it. I have a series of these refactoring videos, and the first one, refactoring a donut, by far the most successful, because there's a particular blob of obfuscated C code by Andy Sloan that there was a buzz about. And this article by Sven here shows exactly what this was all about. On the left, you see this awesome spinning 3D donut with ASCII art, and on the right, you see the incomprehensible code that generated it. Now, a couple years back, when I first did this as my first refactoring challenge, I was able to take, and the incremental steps are shown in the commit history, this using a raw text editor in this 1-hour video, this all the way to that, using just provable refactoring steps. I was executing them by hand in a text editor, but it was all things like renames or extracting parameter objects, all very established transformations, and able again to go from here to here. So by practicing these skills, you can, no exaggeration, deal with a broad category of things that you'd see in the wild, even though this is a toy example. And however, I did kind of hit a wall. You could see, like, at some point I stopped knowing what to call these things. At the end of the day, I was just looking at the context, which was totally obfuscated, single letter names everywhere. And I'm making my best guess about what these various things are, and some of them I kind of gave up. What do we call Z? What do we call O over here? Things like that. So, although I did take it to a point where you're pretty close to being able to see what the trigonometric equations are, and if you did research on trigonometry, you'd probably be able to work with this code. I wouldn't say that it was, finished by any means. So, just as a taste, with no previous prompting, let's dial up into GPT-4 model and say, what do you think this code does? What does this C code do? We'll at least tell it it's C code. Throw it a bone. Now, bear in mind, like, although the original example, right, this code has been widely publicized and likely made it into ChatGPT's training set, I think it's kind of unlikely that my refactored branch is in there. So it has not seen code that looks exactly like this before, very, very likely. So this is, and I think other blobs I've pasted in and asked it the same question confirm this, a decent representation of its ability to know what is going on in some piece of cryptic code. So it says, this C code defines a function called iterate buffer. Okay, that's a safe bet. Just talks about the parameters. It generates a 3D object rendering on the given canvas using ASCII characters. That is absolutely what we're doing. Further, the 3D object is a torus, which is a shape similar to a donut. 10 out of 10 so far, right? The implementation uses a simple ray casting technique. Although my name is Ray and I'm casting right now, I wasn't aware that this was using something called ray casting. And the 3D object just rotated by angles A and B. Okay, that I knew, but quite correct. And then it describes in some detail what's actually happening here. And this, you could freeze frame and look over this if you like and decide whether each individual point of this was right or not. After the function is executed, the canvas buffer will contain the rendered torus, which can be printed or displayed as desired. Now, that's amazing. We got something out of 3.5, which was previously the best model. That was somewhat impressive, but this is especially the fact that it understood that it was the nature of the shape that was being rendered. I find that very impressive. And it also is breaking down what the purpose of the shade array seems to be, right? So that's interesting. That's probably a common pattern that it's seen maybe in other code that generates ASCII art. So the comprehension I'm liking. Now, when you can comprehend, you can refactor. You can identify places where the code's structure and naming doesn't support its intent, and integrate that knowledge into the code. So what if we just simply ask it to do that, right? The code to be clearer. All right, it has defined some constants here. It has extracted a convenience method. Looks like it has renamed several parameters here. Rotation angle A, rotation angle B. Very verbose names, but I kind of like those, so we're good in my book. Losing track of which of these names were originally mine and which weren't. Oh, good. I was just about to ask it to say what it's done here, and it is already summarizing its actions. So it renamed Z to depth buffer, A to rotation angle B, B to rotation angle B, and extracted a method. That's nice. Also add some comments. It's not very self-aware about what comments are actually helping and which are not. Like, if you've got struct canvas and you're commenting it as canvas struct, I don't consider that a very useful comment. But regardless, some of these Pretty nice, huh? Those are useful comments. I mean, I normally try to prefer expressing intent using extract functions and cleared names, but in very dense situations like this, I think that these are quite helpful. Like, for example, here's something I didn't know. It's determining the shading character's index, knew it was doing that, based on surface normal. Now, I don't work a lot with graphics programming. I'm not really sure what a surface normal is. And notice we've hit the length limit on this. So I'm just going to tell it to continue. And a little trick I picked up, continue starting with the markdown to open a code block. Okay, and it was just the, that was the end of the function. Great. Yeah, it's okay, and it's going to start over. Let me just tell it to stop generating that. All right, great. So, again, the level of comprehension, the nature of the suggestions are good. I don't know what the surface normal is in this context, so tell me about that. Maybe if I wanted to add that to the comments, if we were using this to enhance the existing code base. What is the surface normal in this context? Is a vector perpendicular? Okay, this is reminding me of some math class I had eons ago. A vector perpendicular to the surface of the torus at a particular point, used to determine the shading character's index, which represents the shading. So, you're viewing a 3D object, and, the shading is going to depend on what its angle is toward you. So it makes sense that the perpendicular vector would be involved there somehow, I guess. This is really cool. Again, no complaints. And earlier, and I don't know if this has done it without breaking things entirely, but earlier when I took this method and asked it to refactor it, it did produce something that either on the first try or after telling it that there was an error and letting it self-correct, what was still correct code. I haven't had that result universally, though. A lot of times, especially when I'm working with the International Obfuscated C Code Contest entries, which this was not one, but we're going to see one by the same author in a second. It sort of loses its ability. It outputs something that looks plausible and does do something the general thrust of what the original did, but there are bugs in it. It's not able to untangle arbitrarily complex code. So what I'd like to do instead is do kind of a teamwork exercise. I'm going to ask it to suggest changes that I know my IDE will be able to make with more rigor, with more confidence than it does. So that way I won't be relying on this limitation of when will it be outputting something I can literally copy and paste, and when is it actually breaking it while it's improving it. So for that, and I'm open to other approaches here, but something that I've been enjoying so far is this prompt I made called Refactor GPT, which I'm publishing right now in ChatGPT refactoring prompts in the Craft vs. Cruft org. You can find that linked in the comments, or in the description rather. And let's start a new session with this, and I'll walk you through what's in the prompt, little arsenal of tools, and we'll try using it to refactor not the original donut, because we already beat that one to death. We've got 2 hour-long videos on it. But Andy Sloan made another donut in the 2006 International Obfuscated C Code Contest, and it won in the category Homer's Favorite, which I assume they introduced just for donuts. So seeing how handily it handled the original donut, we're dialing up the difficulty now, right? So we got our model set to GPT4. This does work with 3.5, just not as well. And I will walk you through what I've done. I'll start with role prompting, which is a nice thing to do. You are now Refactor GPT, an expert in code maintainability, giving it its point of view in the world. Your input will be code blocks. You will respond by giving the code a letter grade, listing smells by the name only, otherwise it'll go on, and then recommending refactoring steps for the provided code without changing the functionality. Do not break the code. Make suggestions relevant to the code. Only show your suggestions, not the updated code. So very kind of redundant, methodical instructions here that tend to work well. The only available actions, and for my purposes here, I'm sticking to things that mostly the IDE will be able to do, right? So we're able to operate with very high confidence, making a whole bunch of updates. The updated available actions are, I've got renames, inlines, extracts, comments, a few odds and ends, some very basic operations. You can also say weird and flag something strange that should be investigated if you summarize it very briefly. Group suggestions by the function they pertain to. So there's some notes about how to structure this output, and you'll see what it looks like. Bold the action types, so you can tell it how to format its responses. We like names to be honest and complete. When you suggest comments, include the actual comment, because before I said that, it would just say, hey, you should write a comment about what this is about. Yeah, that's not very useful. So if you're going to suggest that, tell me what it should be and describe where it should be. Do not rename macros. Always inline them unless they are string or number literals. That's, we're dealing with obfuscated C code, so a particularly useful hint there. Unless told otherwise, assume all code snippets you see are part of the same program and use that knowledge to inform your suggestions. So this should grow in the amount of context it has. So if you understand all this, respond with your prompt, refactor GPT, and it did. So we're now primed, right? Let us give it the, let's not give it the original code. Let's get it to run first, right? This is Sloan's 2006 entry. It is a donut, and behind, the code has been attempted to be shaped in the form of a checkerboard. We will see why in a moment. So, with our trusty JetBrains editor CLion, which is like IntelliJ but for C, using JetBrains IDE because of the refactoring support is quite good. It is not good as it is in, say, Java, but it's the best C refactoring support I've seen so far. Anyways, let us try and build the project. Now, as is often the case with these IOCC entries, there is a few things that are non-standard that are being done. So it needs some headers that are being just implicitly defined. My compiler doesn't like that. Okay, fine. Include what else we need. Put char is in studio.h. Cool. Can we build it now? Not quite. All right. Only see one error now. The second parameter of main must be of type char star tar. All right. Well, where the heck is main? How about that? All right. So fine. We'll fix that. So undeclared identifier. Okay, all right. Maybe make that more explicit. Yeah, all right, cool. So over the years, the edge cases of compilers shift, but you can usually, with minimal changes, make these work. Now, we can run this guy. All right. Now, it's running a little fast, isn't it? Because it was made in 2006, and I happened to be on one of the new MacBook Pro M1 processors, and they're quite quick. So in order to get this display properly, we're going to have to put in a little sleep. And I think I'll be able to find an inner loop and be able to introduce that. So sleep happens to be in Uni Standard, I believe. And this would be the end of main, right? So assuming there's an inner loop happening in main, then 2 brackets, I could put a usleep. Usleep takes microseconds. So what, 100 milliseconds is 100,000 microseconds? Try that. All right. Going a little slow now. Let's try 10,000. Yeah, all right, that's decent. Now let's run it in its own terminal window instead of the IDE one so we can get a better look at it. All right, so we have, and this is quite impressive, we have a donut over a checkerboard, and then there's this banner that's in the background. So he's really stepped it up on this one. He's got his same donut, roughly the same from before. It's going over this checkerboard, and then it says IOCCC 2006 is what that banner says. So that's International Obfuscated C Code Contest 2006, right, where it was submitted. So very cool. Very cool. Now, what we should have learned for a lot of reasons, but if nothing else from the original donut video where I accidentally introduced a bug like 38 minutes into the video or something, is that we need to have tests before we're going to start messing with this code anymore. And so in the second video testing a donut, I used a method of making this optionally write to a file every so often if there were some environment variable passed, and then all these various steps would be there in it's called golden file testing. I think I have a better way of approaching this now. Which is to just run the unmodified executable and capture its output to a file and then time it out after a certain period of time. And then we're going to run sed on it to take the control sequences that like clear the screen out, replace them with something more ASCII friendly to diff with, and truncate it to just the first 5,000 lines. So let me show you what that looks like. Let's see if that works. Expects a test data directory. That's fine. We could also put make this referred to from make test target or something. That would be fine too. Okay. So it did successfully, according to it, capture some logs. Yep, nice. You can see in the preview here what they all capture. So that's neat. And I'm just going to rename this log file golden.txt. My golden file, and then subsequent runs are going to compare with that using this diff. All right, Great. So we have, technically speaking, a passing test suite. I want to try this one more time here, and instead of a timeout, I want to pipe this through head with n of 5,000 and see if that'll work. Then maybe I don't need the second sed command. Now, even though this program will run perpetually, if it gets a signal that its pipe is no longer present because head has stopped receiving input, it should just break off. But, obviously this is not very trustworthy code. So we'll see if that's actually true. Okay, it failed. It gave a bad return code, but I expect that actually because it did, have to kill the process. So let's try this. I'm not sure if we need both those parens, but whatever. All right. Now that we have a first working example, I'm just going to commit right here. So far, we've got a Clang tidy file that I used before. We've got a little change to the make file. We added our delay and the necessary imports to Sloan.c. And we added our test script and golden file. And let's also, while we're at it, ignore this IDE folder that was created, this .idea. All right, good. That's everything we want. Nothing we don't want. Test data log, because the log will be generated every time, right? That you run the test script. You only want to save the golden file. All right. So in our refactoring branch, we have git code working and add tests. All right, cool. So now we're ready to do some refactoring, right? So first thing that I usually like to do is run this through a formatter. Now, the JetBrains formatter here, usually pretty good, but it's a little out of its depth on these obfuscated C code entries. So I'm going to pull out Clang formatter. Clang format command, which is pretty good at even these level of complexity. So, and I'll save it to a separate file. And then move it to the original. All right, so not amazing, but pretty good here. Now, where I usually go next with these is I follow the state, right? I try to figure out what's being passed around, get things out of the global scope, and slowly extract insight. But we've got our partner, Refactor GPT here. Let's start there. Let's just give it this code. See if it'll all fit. Yep. And I was going to go method by method, but let's see what happens if we give it the whole listing. So it's suggesting some renames in the global scope. Renaming underscore just to underscore is not particularly useful. but X pose and Y pose, X and Y are kind of conventions. O being offset, that's an interesting hypothesis. I'm down to try that. We'll see what it looks like. We've got X equals offset minus 1. I mean, that sort of looks like a reasonable thing, right? End-to-end value, again, that's not a very good suggestion. Okay, rename variable or parameter A and B to angle A and B. That sounds plausible. Now, from experience, I know that something that's going to bother our ability to do our work here is the fact that this is using kind of an old style, default return types. It's not declaring the return types on all of these methods, and then it's declaring some of the types after the signature. This kind of archaic syntax, I know that the IDE is going to choke on where we're trying to update things, so I'm going to try and get past that, but I also want to be very careful not to break anything. So let's just little by little say, okay, this is probably int by default, and looks like this doesn't return anything, so that's probably a void function. Okay, now this L is a char star, this R is a char star. Q by default would be int, and it returns Q, so it definitely returns an int. All right, and the semicolon no longer would be there then. All right. Returning, does it return? Actually, it doesn't return. So we'll call out a void. And int A. Run the test again. Great. So let's make, really main should be an int, I guess. Okay, great. So we should now be ready to take some of these suggestions. Let's rename the methods first. It wants to rename P to render glyph. Actually, let's commit again. All right. It's P render glyph. C, it's calling that right now code to index. E, it's calling render donuts. Fair enough. All right, so then we can do some parameters in. Just being extra cautious here. We haven't broken anything. And sure enough, we have. All right. How could we possibly have broken anything? Okay, so that's a little interesting. Just the act of renaming E seems to repeatedly cause the test to fail. This is when we deal with these obfuscated C code contest entries. This is, the sort of crap we deal with. This is why we have to be very careful on testing, is because this is very strange, treacherous code. So maybe it just couldn't figure out how to rename the reference to it. There's only one reference. Let's just try applying this manually, see what happens. Like, if I call this render donut, and then I change that reference, then it works. Okay, so the auto refactoring tools weren't perfect there. They have failed us. Usually they don't. So regardless, it should now be thoroughly impressed on us the importance of committing frequently. Rename functions. Now let's try renaming some of their parameters. Right? So we'll start with P, now known as render glyph, and num glyphs and glyphcar. Okay, reasonable. It's suggesting extracting a function here. I'm going to skip over that for now. And rename in this code to index code, left and right. All right. In render donut, we have A being the start position. Oh, look at this. It just renamed something in the middle of the string. I bet that's what happened earlier. That's a bug in CLion. That's a JetBrains bug. I should file that. All right, I can pretty easily correct for it. All right, great. So we're still working. Add a comment beginning the function renders a donut. Like, it's called render donut. That is a useless suggestion. All right. So cooking with gas here. In the main function, it suggests to rename k iter. Well, k is an idiomatic name for an iterator, so I'm going to leave it. Z is being renamed args. That is reasonable. I'm actually going to use argv by convention. Great, so now we have renamed the parameters that it initially suggested. Test running, good. Rename params. So I'm going to now do a pass of automation here. Let's take its global suggestions first here. So it looks like these are all ints. It's suggesting O is offset. Seems reasonable. We're doing like x equals offset minus 1. I don't know. That seems like it's being used in an array indices and things. It could be an offset. Probably better than O. A and B are angle A and B. Okay. There we are. We're still good. Good. Now it is suggesting further in the main function the for loop that initializes the Z array, extract to initialize Z array. Not the best name, but perhaps suggesting it to be extracted might be a reasonable thing. But I see this doing several different things. It's not really clear what it's doing. I'm going to leave that be for now. Cool. So I'm going to do a pass of just IDE automated stuff here because you often see in these challenges some code that is not using the optional braces, and as you see we have many compound statements in this one statement, so not using the optional for loop braces is going to leave us unable to break these apart into multiple statements using semicolons instead of the comma operator. So for that reason, I normally prefer this anyway, but it's absolutely vital on the unobfuscated code to add the optional braces. So I'm going to make sure that's been done in every situation it can be. Tests. We've broken it again. How could we possibly have broken it just doing that? All right. All right. I'm just going to make a note of that and do the rest of them for now. Careful adding braces here. Tests broke. Can we at least get the rest of them for now? Great. Commit that. Great. So now let's get back to its main function, which is just we paste some code and it makes suggestions. I mentioned before X to X pose and Y pose. Those not very useful, but it is suggesting changing the ternary to an if. That's a very good idea in this case. Now, it's sort of lost track of the fact that it's not supposed to show me the modified output here. So I'm going to just remind it of some of its prompting. Only show your suggestions, not the updated code, because I think that's just going to be cumbersome. All right. And it apologizes for not following instructions. It's always very polite. Maybe I'll prompt it to apologize less sometime. But yeah, we should commute these ternaries to ifs. So let's see what that would look like. Can we just get the IDE to do it? Beautiful. Dare we get lucky again? How about again? Let's see if the tests pass after all these, because you see there's else 0. That looks weird to me. Let's see. Okay. Okay, so that 0 wasn't doing anything, is what I'm gathering there. If X is else if this, else if this. Okay, yeah, or 0, or 0, or 0. So this is just being called for side effects, these conditions here. So I think it was correct to extract that. This is just strangely written code, is all. Okay. We could really just combine these ifs. Okay. See if it accepts that. Looks good. All right. You see, we've also got the comma operator here, where that should just be two separate statements. Wish there were an automated refactor for that, but there's not. Yeah, probably because real human beings don't normally build statements that way. Great. Code to index looks a little opaque. I don't know if it's going to have much luck with this one, but give it to it anyway. Yeah, it's suggesting the moving underscore to just be called underscore. Convert code to an index using left or right character arrays. That's not adding anything given the signature. For the while loop, add. No, that's what the comment already says. Yeah, this is okay. This one's a fail. Let's see if we could get it to tell us what underscore is, though. As an index to access elements of a hard-coded string. It helps calculate the offset used in obfuscated string decoding processes. Okay. Try renaming it stir index. That's better than underscore. Great. Where are we right now with code here? Okay. Let's commit the convert ternary to if. If you've seen some of my previous videos on code like this, you notice we're doing pretty similar things that we were doing before, but it's, I would have had to spend a lot longer figuring out what I should call various things, where it just gives me something reasonable and I can just move on, because there are just hundreds of these operations that need to be done. Let's, render donut looks like it's relatively simple here. Let's skip over that. Let's just do the big kahuna. Let's do main. See what it suggests. Suggesting k to iter. Again, I don't think that's a very useful suggestion. Rename variable or parameter. N becomes y pose. No, y becomes y pose. Again, that's not very useful. X becomes x pose. Offset stays offset. N value. Yeah, those are lame. For loop, and so I don't really like what it's doing there, because it's saying initialize z array would be the name of the function, but it's calling out that it's got two responsibilities. Now, I tried in my prompt design actually to guard against that. We say we value names that are honest and complete, in the spirit of Arlo Belchi's naming as a process, but it has not got the memo quite, so I'll have to go back to the drawing board on how I'm doing that prompt, because I would like it not to say things like extract something to, something that doesn't express all of what it does. Anyways, nested for loops that update B array, extract update B array. That might be nice. It'd be nice to know what the B array actually is. It updates B and Z both, so I don't think we might be ready to extract just a blob, but we don't know what it's called yet. And look at all that it comes with it, all these things we would have to pass in. So, I think that's a non-starter as well. but you notice here, like, the combination of the AI suggestions and human judgment, um, you know, it's a nice push and pull. It's like a pair programming partner. You know, for the loop that prints B, extract a print B array. Well, that seems reasonable, right? Sure. Now, the name is bad, but we'll get there. All right, and by default, it has the IDE has pulled the signature up here. You could paste this above main and then not include the separate signature. Whatever, it's your preference. I'm not going to worry about that for this exercise here. So what else we've got? Extract function angle update to update angles. Yeah, I don't think that really buys us much. So yeah, we could do angle stuff, but the thing is that's got to update two different things that are local. So I think that's kind of half baked at the moment. However, I've got all this alphabet soup here. You know what can we do? Can we get any better? What is B? Okay, it serves as a frame buffer. So that's better. Buffer is at least better than simply B. So we can use that and print frame buffer, and then we can rename this to frame buffer. See if we can get it to suggest more renames of variables used in main. Okay. Split to separate declarations. Nice. Yeah. In fact, I'm not going to say sine angle A there. I'm just going to say sine A. And this is very similar to what I did when I refactored the original donut. It's like, I don't know what else to call it, but I do know that it's the sine of something called B, so we'll call it sine B. At least then, you know, we'll be able to trickle down and see what's going on in the equations. Cosine A, cosine B, GM. Okay, we got all these. Variable or parameter ij to angle I and angle j. Now, we don't typically, by convention, you know, label angles I and j, which is why I went with theta and phi. I think it might also be possible to call them like pitch and yaw, but that's what I'm going to do on this one. But good idea to change them. So then C becomes sine of I, really, and we'll break up these declarations again. All right, and we just carry over these suggestions. I don't know what cosine theta plus 2 is meant to be. They're just calling it plus 2 there. I'll call it incremented cosine theta. Something. I'm on thin ice there with that name. D distance. All right. You still good? Might be a distance. Distance of what? You know? I think that leaves questions yet. And T is some temp value? I don't know. I don't accept that. Like, I'm gonna hold off on that one. Having done all those, though, we can just iterate on it. We'll, while it's churning on that, we will commit. Renames. All right. It's got some suggestions we already decided not to do. Z array, initialize Z array. We don't like that suggestion. Nest the for loops that update the frame buffer array based on angles. Extract those to update frame buffer. That's not bad, actually. It's not a bad name. Before it was saying like update Z array or something. Now, what does that require to be passed into it, though? So I'm trying to see what I can extract out without taking too much with it, and I see that sign B here is used both in this block and in here. None of these others are. So I guess we could, if we absolutely don't want to calculate it more than once, then we can pass it in and then compute the rest of these in this block. However, also be an argument you can make that you should just calculate it twice and take the extra performance hit, especially given in this situation where already, introducing delays just to make it run slower, right? So we're not really at a performance bottleneck. I'm going to take my own advice here, actually. You could do it either way, but I'm going to just duplicate that variable, give it a temp name so it doesn't overlap, and then extract this update frame buffer. And we pass in angle A, angle B, theta, and phi. Why do we do theta and phi, though? They are just existing in the span of this loop, completely updated in there, right? But they're declared up there. Well, they don't need to be, right? So let's split these declarations and move theta and phi there. And in fact, I assert that they should just be declared in the loop. Are we all good before the method extract? Yes. Okay. We're still following the advice, but you see it took a little bit of our own action to do that. So we're going to call that update frame buffer, I believe. We could focus more on the main method, or we could get deeper into this update frame buffer. Let's try this again. Okay, it's now calling offset buffer offset it's gained a little bit of context there. That's interesting. If Z is the buffer, that could be right. Yeah, frame buffer offset. Okay, yeah, it's the buffer offset. I buy it. But what is Z? Z is an array of floats that represents the depth buffer. It stores the distance of the currently drawn point from the viewer for each position in the frame buffer. Ah, it's the depth of every point that we look at. Okay. Well, then it sounds like it is implicitly suggesting, although it didn't include that in its suggestions, that depth buffer would be a pretty good name, would it not? Let's change that in both places. At the beginning of the function, add this comment. Okay, I mean, sure, why not? It doesn't add a lot to the method signature, but I'll give you this one. Okay, we got some wonky formatting here. I'm just gonna do. Oh, it did not make it any less wonky. Let me try and suggest. Okay, sure. And I noticed this last bit about the depth buffer. If the new point is closer to the viewer than the previously drawn point, it will be drawn, and the depth buffer will be updated accordingly. That basically is saying what this is doing. And I think that's kind of a reasonable description. Break the commas into separate statements there. Add braces. And this explains why it's happening. Nice. Notice there's some magic numbers in here. One of the magic numbers in, it was still pointing out code smells. Its prompting has started disintegrating here. If it still remembered its prompting, it would have said probably that there's a magic number code smell in this. What are the magic numbers? All right. It recognizes 2 pi. Excellent. Extract a 2 pi constant. 07 and 02 are step sizes for theta and phi. True. And the phi step. We're going from 0 to 2 pi, by the way. That is an angle in radians that we're going in the full rotation of a circle, if you remember your trig. So, 15. This value is used as a scaling factor for calculating the distance in the original code, or D, or distance in the refactored code. This is interesting. It sort of has a model. It is referring to both the original and the refactored code in referring to a variable. So it's kind of got a picture of what both of these are. That's just amazing. To a point on the torus surface, it affects the size of the rendered torus. Okay. So 15, maybe we call it a scaling factor. Five, added to expression, it affects the shape and size of the torus. Okay, that's a little vague. Offsets for the X and Y position when projecting the 3D points onto the screen. So that's true. This is the X offset, and that is the Y offset. Doesn't really say much more than that, so we could extract their names or not really there. 80 is the width of the frame buffer. That makes sense. And there are quite a few occurrences of that. Test still good. So let's commit constants. So this is pretty neat. Now we've seen a lot of the donut code. This looks very similar, and actually ChatGPT's suggestions are pretty similar to what I ended up with in the first donut video. But you recall there's if we run this guy, there's quite a few components to this. So really we've only learned through this refactoring journey about the donut itself. We haven't really learned where the checkerboard comes from or where this neat scrolling banner comes from. So I don't know how much longer I wanna milk it for this video, but those would be the next steps here. And in fact, the fact that this update frame buffer seems to be rendering the donut, this is the part with like the torus calculations, makes me think that this part may not be named correctly. That initial suggestion may have been wrong. Let's take it out. Let's see what we get. It would fail the test, obviously, but if we just run it, all right. Well, what's not happening? The background, the checkerboard, still happening, but the banner is not. So I'm going to say that actually, and GPT wasn't able to catch that, but fine. Render banner. See what it says at the moment. Okay, so it is completely forgotten what it is supposed to be doing. That's fine. We'll just re-prompt it a little bit. We could also start another session, but whatever. So I'm just going to say remember, and then just And then just paste the Refactor GPT prompt back at it and give it this render banner function. All right, so smells. Yeah, it's remembering to do the smells again. Poor variable names, magic number, complex for loop. So start pose to start position. Those are just abbreviations. I don't think that's actually a problem. What names could you give those magic numbers? Yeah, it's really not. It doesn't have a lot of ideas on this one. Um, 34. What is it? That's. Oh, we'll try it. Six is something the left size. This is the right size, and then the respective offsets. These could be constants instead of variables. Not really worried about that right now. It's right size. All right, test still good. Suggesting buffer offset become buffer index. Index and an offset, kind of the same thing. I guess that's reasonable. Add comment function iterates through string and performs a calculation based on the past code, left and right strings. The result is an index into left or right string depending on calculation. What are the smells? I like that it says the comment warning about adding braces is a smell. I agree. That was a smell. So, what would you call the magic numbers in code to index? Any alternate names for code to index? So let's just take these uncritically for now. Because, doesn't take much to undo it. Charbase offsets. I wonder if we looked at an ASCII table if that would be something significant. Now we take this and we do, bitwise manipulation here. This bit shifting, that's strange. I'm not surprised that it's not able to figure out, what is actually going on here when it's that crazy. And then it's calling this char code offset. And you know, it might not be perfect. It's probably better than what it said before, right? I'm noticing we're manipulating a global here. Like, this is the sort of thing where when I do these by hand, that would definitely be something on my radar. It's like, get this state out of global and into being passed through the functions in a chain of custody, where we see exactly what's the input and output to everything. But there are other videos in the series where we have good examples of doing that. So I'm curious, something we haven't gotten into yet is like, where does this checkerboard come from? We established that if we take away the render banner, the banner goes away. I don't really know what this loop does. So, and I noticed that it's got dots and pound signs, which make me suspicious. Well, for a moment we saw the donut. Yeah, it's attempting to render here, and then we do see the banner working correctly. So it looks like, and the checkerboard did disappear. So this is doing the checkerboard, but that's not all it's doing. What if I made, because it looks like this and 1, so this will always be either 0 or 1. If I made both of these options space, let's say, then what would happen? Yeah, then we take away the checkerboard. So basically that is sort of doubling that block, I believe, of drawing the checkerboard, but also just resetting the frame buffer so there's not a bunch of old data left. So that kind of tells me its intent. So I'm going to undo those changes, and then after testing and committing, I'm going to extract that into a method and give it a name based on what I now understand. I'm going to call this render checkerboard, and this is passing back this K, which is a little weird. Like, we're passing K in and passing it out. I'm going to undo that extract and get to the bottom of this. Because when we do print frame buffer, we're passing in K, but then we're just assigning to it, like using it as a loop iteration variable. So I don't think this really needed to be the same K. So we just, maybe just don't pass that in. Take it out of the declaration as well. And then similarly, let's just not, and this is for no good reason, right? Just obfuscatory reasons. The number of arguments was then, which is the first arg to main, was being, used then as a loop variable. It didn't need to be. It could just be redeclared right here because it was reassigned anyway. So now we are ready to extract render checkerboard. And there's a calculation of sign B1 there, which is only used in there. Remember, we duplicated that so we could decouple the code. I wonder why we needed to take the sign of something in order to draw a checkerboard. Something to do with 3D perspective, maybe. Okay, nice. So now we've got a fresh new blob of code. I mean, it's seen it for other reasons in as part of main, but when we give it this little blob where it's named appropriately, maybe it'll have some better suggestions. And for good measure, I'm also going to split all these comma operators into separate statements. So we're an automated way to do that. All right. Good. It's remembering its prompting. It's giving it a grade of B, which is a little generous. Smells just catching the magic numbers. All right. And it's again suggesting replacing the magic numbers, but it's not telling us what to call them, which is like, it's fair. It's like hard to figure that out. It's not obvious, so I understand why it's not doing it, but maybe we ask it nicely. $1840 total buffer size. Yeah. I'd buy that. Because we are looping over that and using K as our index into the frame buffer. So I think that is what it is. And probably you could compute that with width times height, right? Y offset, interesting. I guess it's an offset. X offset base is 41. And then 40 is F. X offset divisor. Honestly, like, that might make sense, but I'm totally confused by that between 40 and 41, so I'm not going to take that suggestion. What about N? Angle offset? Maybe. Where else is that used? Anywhere? Yeah, it's using update frame buffer, but it's just assigned and then used. Now tracking the life cycle of this variable, let me use my word boundary regex there. So it's assigned there and then immediately used. And then it's assigned here and then immediately used. And nowhere else. So this doesn't need to be global at all. That's just weird life cycle there. So I'm just going to declare it both times that it's used. Okay, so what have we done here? We've extracted the render checkerboard. Yeah. I definitely encourage you to play with this on your own. If we were to go back to the notes that came with the International Obfuscated C Code Contest entry, they come with puzzles, right? So can you change the shading of the donut and the checkerboard? I think now that we've seen that, we would be able to, because it's clear to us now that this is the shading of the checkerboard. So we just change that, like we did earlier. And under render donut. Actually, it's under update frame buffer, but maybe it should have something about a donut in it because there's multiple components now. Yeah, that's how we would update the shading of that. We could even extract those, to constants with names and things. There's always more things we could do. So that's how we would do that. Can you change the movement rate of the donut, the checkerboard, and the scrolling logo? I think now things are in enough pieces that we would have no trouble doing that. Other puzzles are, can you change the inner and outer radii of the donut, the height and scaling of the checkerboard? Might take a few tries, but I think we would at least know where to look now to start to play with those constants. We'd probably figure that out fairly straightforwardly. How is the IOCCC 2006 logo encoded, and can you put something else in its place? Can you find a smaller encoding? So that would be the banner, right? Now, in this case, we're passing in these left and right strings. Notice these are broken up on lines, but this is actually one string, and this is one string. So that's another, improvement we could easily make to pull those strings into one line. But then we're doing this weird bitwise arithmetic. So I'm willing to say on this one that no idea how that logo is included. But after one medium-sized session here, we're able to get things in a very readable spot, and I think definitely this refactor GPT prompt, this interactive process, and being able to ask for little extra segments of insight, being able to leverage GPT's pattern matching absolutely accelerated this process. It may not have completely replaced it, but I'm very excited about the possibilities here. I just think when you're working with LLMs, large language models, you need to not lose sight of the fact that you can't always infer what its capabilities are. It's not like working with a computer as you know it. There are things that computers are very good at that it's not very good at. And there are things that it's very good at that computers usually aren't. And just the same as it's not like people either. There are things that it does better and things that it does worse. So basically, we need to think about the best ways for, conventional algorithms and LLMs and humans to work together in synergy. What's the feedback loop that's going to allow us to really have the best results? And remember what Lao Tzu said in the Tao Te Ching, with patience, the most tangled cord may be undone. Thank you.